We're going to take a look at worksheet number 14 here on our two-dimensional forces. We start off with question number 1, where we have an object like this. Don't even know what the mass of it is, but it doesn't matter. Being pulled downward with a force of 130 newtons and being pulled to the right with a force of 200 newtons. We're going to call this force right here F1, and we're going to call this force here F2. Although it doesn't really matter. We could have easily switched those around and called them F2 and F1, or we could have called them FA and FB, or FX and FY, whatever we really wanted to call them here. This question is a little bit more straightforward than some of them. Some of you yesterday were trying to do this, however. It's more straightforward, it's simpler than some of the other questions, but it's not as simple as some of you were trying to make it. Some of you just connected the ends of the arrows there with a little line, as I have drawn there in red, and said, oh, why don't I just find the hypotenuse? Why don't you do it that way? Because you'll get the wrong direction that way. The net force, which is what we're looking for here, is a vector, which includes direction. And if you just do this, you'll get the magnitude correct, but you will get the direction wrong. So what you got to do is change it from a free body diagram. And that's what this is, right? It's a free body diagram. Change it into a vector diagram. I get 200 meters this way, 200 newtons this way, and I have 130 newtons this way. Now this is a vector diagram. You can see that because it's drawn head to tail. This is what we want. The resultant vector now will be the same magnitude as the one that I had drawn incorrectly a minute ago, but it's going to be a different direction. It's going to be the correct direction. So let's find the value now of r. We're going to say r is equal to, the magnitude of r at least, is equal to the square root of 200 squared plus 130 squared. Let's do this on the calculator. Let's say it's the square root of bracket 200 squared plus 130 squared. That gives me a value of 238. Or we're going to say 239, I guess it would be, 239 newtons. And theta is always found by using the inverse tan function of opposite over adjacent, 130 over 200. That's going to give me a value of 33 degrees, 33.0 degrees, in fact, and that's going to be south of west. Notice I'm measuring the angle. Sorry, not south of north. What is that? Never see south of north. That should be south of east. Measuring it from the east, but yet it's going south from the east. Now, you could have also said 239 newtons at 57 degrees east of north. Anybody say that? 57 east of north? Okay, that would be correct. Okay, that would be correct. All right, question number 2, a little bit more complicated. This time we have 3 forces acting. We've got a force acting this way of 20 newtons. I'm going to call this F1. We've got a force acting this way of 20 newtons. I'm going to call this one F2. And we've got a force acting this way of 60 newtons. I'm going to call that F3. Now, some of you are going to look at this and say, I'm going to take a shortcut and just combine the 20 and the 60 and make it a 40 newton to the right. That's okay in a question like this, but I would suggest you still go through the method, the X and the Y method, because this is a fairly easy question, right? Let's get the method mastered on the easy questions, so then we don't have to worry about that method when we get to the hard questions, because we've already mastered it, right? If you skip steps and take a shortcut here, then the harder questions seem even harder because you've got to learn a method at that point. So I'm going to say for this, sticking with the method, the x component of the first vector is negative 20. What's the x component of the second vector? Haley, what's the x component of the second vector here?
The second vector?
Yep. Right. The x component of the third vector? Aoife?
X component of the third vector?
Yep.
That would be 20.
Nope. The third vector right here. So now you could have named them differently than I did, right? But we're talking about the third one right here.
So that would be 60.
Yes, good, 60. So we're going to add these up, and that's going to give us 40 newtons. And now let's find the y components. Now what's the y component of the first one here? Good, 0. What's the y component of the second one, Kelvin? Positive 20, good. And the y component of the third one, what's the y component of the third one, Aoife? 0. Add these up, we get 20 newtons. Now we just combine these, right? Draw a new vector diagram where we have 40 to the right and 20 up. And the resultant vector is going to be drawn from start to finish. R is equal to the square root of 20 squared plus 10 squared. Sorry, 20 squared plus 40 squared. What does that equal? 44.73. Should be 2 digits, I guess, so it would be 45 newtons. And theta, Parker, what was the value of theta there? The inverse tan of 20 over 40? 27? 27 degrees, and that's going to be north of east, right? We're measuring our angle from the east, but yet we're going north from the east. Right? East, but north from east. So 27 degrees north of east. Or you could have said 63 degrees east of north if you had drawn it differently. And finally, question 3. They keep getting progressively a little bit harder, right? Question number 3 gives us 2 forces, this time not 3, but we've got a funny angle in this one. This time it looks like this. I'm going to call this one F1. It's a value of 40 newtons downward. And then this one I'm going to call F2. That's a value of 100 newtons, but it's at an angle of 30 degrees right here with the horizontal. What's the first thing you notice there? Braden, what's the first thing you notice in this question? There's a funny angle. We don't like funny angles, so we take it off to the side and we get rid of it. This is X. This is Y. This is 30 degrees. So let's say cosine 30 degrees is equal to adjacent over hypotenuse. X is the adjacent side. 86.6 newtons. And then we're going to say sine 30 degrees is equal to opposite over hypotenuse, or y is equal to 50 newtons. Let's box that up. If we want to, we can redraw this. We don't have to, but we can. I'm going to say it's 86 this way, 86.6 this way, and I'm going to say it's 50 newtons this way, and I'm going to relabel this as F2. Now, it's almost like question number 2 was. It's like we have 3 vectors here, but all at 90 degrees to each other, which makes it easier. So I'm going to say X component and Y component. With the numbering system the way that we have it numbered, okay, what is the X component of vector 1? Taryn, what's the X component of that 40? 0, good. What's the X component of F2? What's the X component of F2? Megan? 86.6 newtons. Good. Positive? Yep. Because it's to the right. What's the Y component? Whoops. Shouldn't have put it there though, right? Should have been right here. Add these up, get 86.6. Luke, what's the Y component of the first vector? Negative 40. And what's the Y component? Evan, what's the Y component of the second vector? Yeah. Nope.
Is that 0?
Nope. Well, if you're looking at this as a second vector, you could say 0, but I'm looking at this whole thing here as a second vector, right? This whole thing, because really that was the 100 that I broke down into 86 and 50.
Well, usually I just 50.
Yeah. So if you wanted to make it 3 vectors, negative 40, 0, and 50, that's fine.
Usually don't do the zeros, and I just take the lines.
Yeah, like I did there. Okay, yeah. That's usually what I do too.
I just get caught up because I didn't get the 0.
Well, I did the 0 thing over here, but for this one, I don't do that, right? Okay. Does it make sense? Okay, good. We got 86.6 newtons this way, and we got 10 newtons this way. And our resultant vector goes from start to finish right here. Find the value of R, find the value of theta. I think R to 2 digits works out to be 87 newtons, doesn't it? Square root of 86 squared plus 10 squared is 87. And theta was pretty small. I can't remember what it was. Yep, 7 degrees, 7.0 degrees. Actually, I think it was 6 point something, wasn't it? 6.6 degrees. 6.6 degrees. Now, we're measuring that angle from the east, so we're going to say it's of east, but it's north from the east. So we're going to say it's 6.6 degrees north of east, north from east. Good? Okay, I'd like you guys to take a look yourselves at question number 4. Treat that as your little practice quiz. We're going to have ourselves a real quiz on Monday. One question just like this. Okay, number 4 is a pretty representative example of what you might see on that quiz. All right, you've had a chance to finish this. Now let's take a look at it ourselves here as a group. We have our object. We're pulling it down this way with a force of 50 newtons. I'm going to call that F1. We're at an angle of 30 degrees here as usual. We've got another force down here. This is 100 newtons. I'm going to call this F2. And that's also at an angle of 30 degrees here. We got 2 funny angles, so we have to take them both off to the side and deal with them. Let's do that now. 50 newtons first. This is X, and this is Y. This is 30 degrees. If I want to find the X component, it's the adjacent side of the triangle, so I'm going to use the cosine trig function. 50 cosine 30 gives me 43.3 newtons. And I'm going to find the Y component using the sine function because it's the opposite side, gives me 25 newtons. There's one of my vectors off to the side there. So let's actually redraw this. We don't have to, but I will. I got 43.3 newtons this way, and I have 25 newtons this way. I'm calling this F1. Now, F2, we're going to draw off to the side as well. 30 degrees right here. This is my X component. This is my Y component. And my number here, my hypotenuse, what was it? 100 newtons? The X component is the adjacent side, so we're going to find out we're using the cosine function. Gives me a value of 86.6 newtons. And the Y component using the sine function is 50 newtons. So box that off. And if you want, redraw it. Redraw it so that we have 86.6 newtons over this way. And we have 50 newtons down this way. We're going to call this one F2. So now this question is almost exactly like question number 2 is. We don't have any funny angles. We just have a few vectors that we got to add together. Let's do that right now. The X component and the Y component. The X component of the first vector is negative 43.3. And the X component of the second vector is 86.6 newtons. We add those up, we get 43.3 newtons. And the Y component of the first one is negative 25. The Y component of the second one is negative 50. That gives me negative 75 newtons. Now this is easy, right? 43.3 this way. And 75 downwards. The resultant vector is what I'm looking for here. The sum of the vectors, the resultant vector. What does R work out to be if I do the Pythagorean theorem there? Works out to be 87 newtons, thank you, to 2 digits. And theta is going to work out to be 60 degrees. And that's going to be south of east. Why south of east? Because we're measuring it from the east here, but yet we're going south from the east. If you had drawn it differently, you would have gotten 30 degrees east of south. Both of those would be correct.